In this video, I will show you how to solve separable differential equations. In this method, we treat dy dx like a fraction, and our first step is to separate out the equation so that we have the factors of y on the left and factors of x on the right. For example, on this problem, we could cross multiply. So, when we multiply y squared by dy, we will have y squared dy on the left side of the equation. Similarly, on the right-hand side, we will have 3x squared dx. Now we can integrate both sides of the equation. The antiderivative of y squared is 1/3 y to the third power. Normally we would put a plus c, but you don't need a plus c on both sides of the equation, and I'd rather put it on the right-hand side. The antiderivative of x squared would be x to the third power, and then I would divide by the 3. This coefficient of 3 divided by 3 is 1, so that's gone. And now I will put the plus c. This counts as a solution to the differential equation. However, sometimes they will ask you to write your solution in the form y equals a function of x, so I'm going to show you that as well. Multiplying both sides of the equation by 3, we have y to the third power is equal to 3x cubed plus 3c. Taking the cube root of both sides of the equation, we have y equals the cube root of 3x to the third power plus. Instead of writing 3c, I'm going to write d, because c is a constant, and 3 times c is just another constant. Let's call it d. So here is the solution in y equals f of x form. By the way, when they say find the general solution to the differential equation, the word general refers to the fact that we have these unknown constants of integration, c or d. When they say find the particular solution of the differential equation, they will give us some extra information that will allow us to solve for the constant. On number 4, let's cross multiply again. That gives us 2y to the third power dy equals 6 minus x squared dx. Now let's integrate both sides of the equation. For y to the third power, when you integrate, it becomes y to the fourth power. Then you divide by the 4. 2 over 4 is 1/2. On the other side, the antiderivative of 6 is 6x, and x squared becomes x to the third power with a 1/3 in the front. And let's go ahead and put the plus c. This is a perfectly fine solution, but let's see what it looks like if we get y by itself. Multiplying by 2 on both sides, we get y to the fourth power is equal to 12x minus 2/3 x to the third power plus 2c. Now, taking the fourth root of both sides, we get y equals the fourth root of 12x minus 2/3 x to the third power plus 2 times c is just another constant, which I will call d. I almost forgot, when you take an even root of both sides of the equation, the solution will be plus or minus, so don't forget that. For number 6, I could put a 1 under here and look at the next step as cross multiplication, or I can think of it as multiplying both sides of the equation by ds, and that would cancel these out. Either way, on the next step, I'm going to get dr is equal to 0.75s ds. Now I'm going to integrate both sides of the equation, and this is like the integral of 1 dr. The antiderivative of 1 will just be r, and this s will become s squared, and then I need to divide by the new exponent. So it will be 0.75 divided by 2 plus c. And that's it for number 6. For number 8, I would start by rewriting y prime as dy dx. I need to get all of the y factors on the left and the x factors on the right. First, I think I will multiply both sides by dx. So the dx's cancel each other out, and I have x dy is equal to y dx. Somehow I need to get the y over on the left and the x over on the right. So I can do that by dividing both sides by each factor. So if I divide both sides by y, that's going to cancel these out, and I'm going to end up with a y over here on the left. But I can simultaneously divide both sides by x. That'll cancel these out and leave an x over on the right. So let me just show that. So these x's will cancel out, and these y's will cancel out. So on the next step, I will have 1 over y dy is equal to 1 over x dx. If I now integrate both sides of the equation, I remember that this is a memorized rule. This will be the natural log of the absolute value of y. And this will similarly be the natural log of the absolute value of x and plus c. So here is a general solution to the differential equation, but let's try to get y by itself. To get rid of the natural log, I can exponentiate both sides of the equation. In other words, drop a base e on both sides. The base e and the natural log are inverse operations, so they cancel each other out. On the right-hand side, I kind of want to do the same thing with the base e and this natural log, but I can't because it's not just natural log. It's natural log and then plus c. So you can't just cancel out part of it, not the other. So what do? I am going to use properties of logarithms to turn this into a product. What am I talking about? Imagine that I had e to the a power times e to the b power. When you multiply with like bases, you can add the exponents. So you would end up with e to the a plus b power. But guess what? This process is reversible. So if I started off with e to the a plus b power, couldn't I then rewrite that as e to the a times e to the b? Sure I could. And that's the situation I find myself in here. I have e to the a plus b. And I can rewrite that as e to the a times e to the b. Now the base e and natural log will cancel each other out, and I am left with the absolute value of x times, look, e is a constant and c is a constant, so e to the c is just another constant. Let's call it d. To get y out of an absolute value, all you need is a plus or minus, similar to what happens when you take the square root of both sides of an equation. So I will have plus or minus, and I think I'll put the d in front. So plus or minus d absolute value of x. So here is the y equals f of x version of the solution. Ooh, trig functions. First, let's rewrite this replacing y prime with dy dx. If we multiply both sides by dx, it'll move the dx over here. let's integrate both sides of the equation, and I'm choosing to leave the negative 8 out in front. On the left-hand side, the antiderivative will be 1/2 y squared. And then let's do some mental u substitution right here. Let's let u equal pi x. That means u prime is just pi, which means that when we do the antiderivative, we will end up dividing by pi. So we're going to have negative 8 over pi. Other than that, we can just take the antiderivative of cosine u. So the antiderivative of cosine u is sine u plus c. So this is one form of the general solution to the differential equation. Let's see if we can find the version that has y by itself. If we multiply both sides by 2, it'll cancel out the 1/2, and this will become a 16. Also, we have 2c. So let's take the square root of both sides to get y by itself. Don't forget the plus or minus. Remember, 2c is just another constant. Let's call it d. For number 12, let's start by rewriting y prime as dy dx. Multiplying both sides by dx will move the dx over there. I want to get all the x's on the right-hand side, so let's divide both sides by this radical. So we have this. Now let's integrate both sides. On the left-hand side, the antiderivative of 1 is just y. On this side, let's do some u substitution. So let's let u equal everything under the radical, which is x squared minus 16. U prime equals 2x. Now we have the integral of 11x over the square root of u. Instead of dx, we write du over u prime, which is 2x. We notice that these x's will cancel each other out, and we still have the 11 over 2. So let's put the 11 over 2 way out in the front. So now we have this, but 1 over u is the same thing as u to the negative 1/2 power. So using the power rule of integration, we will increase this exponent by 1, which will make it positive 1/2. And then we will divide by the new exponent. Dividing by 1/2 is the same thing as multiplying by 2. If I multiply 11 over 2 by 2, the 2's cancel out, and I just get 11. And don't forget the plus c. So we have y equals 11 times u to the 1/2 power plus c. U was x squared minus 16. So this is y equals 11 times the square root of x squared minus 16 plus c. So this is a general solution to the differential equation, and it's already in the form y equals f of x. Let's do one more. Once again, let's begin by rewriting y prime as dy dx. We want those x's on the right-hand side of the equation, so a good step would be to add 7e to the x to both sides of the equation. On the next step, I want to multiply both sides by dx, so the dx is going to end up over here, but also let's go ahead and divide both sides by 12. I like to have my constants over here with the x when I can help it, so I'm just going to have the 12 over here, so it'll be 7/12. So now we have this. Let's integrate both sides of the equation. The antiderivative of y is 1/2 y squared. The antiderivative of e to the x is e to the x plus c. And we still have the 7/12 out in the front. If they just ask you for a general solution to the differential equation, you can stop here. But if they ask you to find y equals f of x, you have to keep going. Let's multiply both sides by 2. That'll get rid of the 1/2, and multiplying by 2 over here will cancel out the 12 and make a 6. Multiplying by 2 also turns the c into 2c. Now let's take the square root of both sides. So here's the y equals f of x version of the solution. Don't forget your plus or minus, and notice that 2 times c is just another constant, which I called d.